Okay, so welcome back, and today we're going to start linear functions. And so we're going to start with the definition of what a linear function is. And so again, this is just intro. I'm going to talk a little bit. So again, just a real short video on this, and then we're going to do some examples. So a linear function. So if we have a function f, we're going to say that the function is a linear function if for real numbers a and b, we have this relationship. Okay? If it has this relationship, if we can find real numbers a and b such that this is true, right? F of x can be defined this way, or in other words, if we could put the function in this form, then we know it is a linear function by definition. Now, if it is a linear function, as long as a is not equal to 0, because if a is equal to 0, then all we have is a constant function, and so this won't be true. Okay, but if a is not equal to 0, then the domain and range of this function will always be both negative infinity to positive infinity. So the range and the domain and the range are going to be all real numbers. Okay, so again, if you have a linear function and a is not equal to 0, then we know that the domain and range is going to be all real numbers. Okay, and that's the definition of a linear function. So what is a linear function? It's a line, right? So if we think about a line, graphing a line, we take 2 points. Let's say the intercepts are good places to start, and we plot the line. Now, usually you only, for a straight line, for a linear function, you only need 2 points to graph, sketch the graph of a line, okay, a linear function. But typically we would use 3 points, the third point is usually as a check, but you really only need 2 points to graph any straight line, okay? So, but you could plot a third point and it'll be one just as a check, okay? But that's it. That is the definition of a linear function. And so now next time we're going to talk about examples.